What's good, crew? Back at it again with SAT Hijackers, where we hijack the SAT one question at a time. We're running through geometry from practice test 6. Let's just get right into it. Here we have a pretty simple angle problem. It states, in the figure, two lines intersect at a point. Angle 1 and angle 2 are vertical angles. The measure of angle 1 is 72 degrees. What is the measure of angle 2? So all you guys need to know is just a simple concept. Vertical angles are congruent. Therefore, since both angle 1 and angle 2 are vertical angles, we can set them equal to each other. So angle 1 is equal to angle 2. So therefore, angle 1 is equal to 72 degrees, which makes our answer A, as angle 1 is equal to angle 2. So here we have a triangle problem. It states the figure shows the lengths in inches of two sides of a right triangle. What is the area of the triangle in square inches? So we're going to draw the formula for the area of a triangle. So area equals 1/2 base times height. So I'm gonna write out our base and height. 5 is our base and our height is 3. So we're gonna say A is equal to 1/2 our base times height, which our base is 5. So we're gonna have 1/2 5 and our height is 3. So we're gonna have 1/2 5 times 3. Now we're just going to simplify our equation. So we're going to have area is equal to 1/2 5 times 3, which is 15. So 1/2 of 15. We're going to simplify even further. So we're going to have area is equal to 15 divided by 15 times 1/2, which is the same as 15 divided by 2, or 7.5 if you simplify it further. Hey guys, here we have another question. This is a really tricky proportion question that a lot of people wouldn't get. So it states in the right triangle ABC, angle C is the right angle and BC equals 162. Point D on side AB is connected by a line segment with point E on side AC such that line segment DE is parallel to side BC and CE is equal to 2AE. What is the length of line segment DE? So I'm going to write down BC equals 162 on the diagram that I built for you. And it says CE is equal to 2AE. So I'm going to write AE as X. So I'm going to have 2X for my AE and X for my BC. For my EC, pardon me. So now I'm going to create a proportion. I'm going to have ED over CB. And now I'm going to have to find out the other part of our proportion. So we want to find our whole, which is AC. And AC is made out of AE and EC. So we're going to add these two together. So we're going to have AC is equal to AE plus EC. Plus EC. And now we're going to convert that into their variables, which is 2x and x. So AC is equal to 2x and EC is equal to x. We're going to have AC is equal to 2x plus x. Now we're going to simplify this equation. So we're going to have AC is equal to 3x. And now we're going to write that for our other side of the proportion that we have. So now we're going to say ED over CB is equal to EC over AC. So now we know EC is equal to X and AC is equal to 3X. So our proportion is in the format of part over whole. And this is why we have both at the top as a part of the whole shape of our triangle. So we're going to input our numbers. So we have ED, which is still missing. So we're going to have it as ED. Then we have CB, which we know is 162. So we're going to have 162 as our denominator. We know EC is equal to X. So we're going to have X as our top number. And we know AC is equal to 3X. So we're going to have 3X as our denominator. And now we have to simplify this right side of our equation. And we know there's an invisible 1 in front of our x. So we're going to cancel out our x. So we're going to have ED over 162 is equal to 1/3. So we know that the proportion of ED over 162 is is equivalent to 1/3. So we have to divide 162 by, you have to multiply both sides by 162, which is the same as dividing it by 3. So we're simplifying to get our answer for the proportional answer for ED. So we're going to have DE, which is the same as ED, is equal to 54. So our answer is 54. Here we have a trigonometry problem. The question states, right triangle ABC is shown. What is the value of tan A? Since this is trigonometry, I'm going to draw our trig ratios and the abbreviation for it, which is SOHCAHTOA. So I'm going to draw my Using SOHCAHTOA, we can say tan is equal to opposite over adjacent. Now that we know what the trig ratio for tan, we can represent angle A as x and find our opposite and adjacent sides. We know that line CB is our opposite sides as it's directly across from our angle A, so we can say line CB is opposite, and we know line AC is adjacent to angle A as it's directly touching our angle. Using the knowledge that we gain from this diagram, we can now determine that our angle A is equal to 60 degrees. How we came up with this answer is through subtracting the total amount of angles inside of a triangle, which is 180 degrees, by the amount of angles that we know, which is 90 degrees at angle C and 30 degrees at angle B. So 180 minus 90 minus 30 will help us determine what angle A is. So we have 180 minus 90, which equals 90, and we subtract 30 again, which ends up with 60 degrees, which makes angle A 60 degrees. And if you guys are familiar with special right triangles, we now realize that the diagram that was given us now represents a 30, 60, 90 special right triangle. So now I'm going to show you guys the properties of a special right triangle. So we're going to have a 30, 60, 90. So we know our hypotenuse on a special right triangle its proportion is 2x, and we know that the side leg, our height, has a proportion of x, while our base leg has a proportion of x through root 3. So to find tan A, we're gonna have to solve for x. So we know that our hypotenuse of the triangle that was given to us is 54, and the hypotenuse equal to 2x. So to find x, you have to do 2x is equal to 54, subtract both sides by 2 to solve this two-step equation. So we're going to have x is equal to 27. So now we have x is equal to 27. We know that our side height leg is 27. And our base width leg is 27 root 3, and those are adjacent and opposite sides. So now we can input this into our trig ratio. So we have tan A is equal to 27 root 3 over 27. And now we just have to simplify and erase our 27. So we have tan A is equal to root 3. Tan A is equal to root 3. Therefore, our answer is C. Answer is